Hello everyone, this week and next week we do experiment number 5. So this experiment is gonna be on your lab canvas. So this week we're not gonna do lab on lab archives. So this whole modules were prepared for you to complete this experiment number 5. So make sure you read the introduction first and complete it as we move from top to bottom step by step. And if you look at these modules package, you're gonna see there are many videos were used to show the instruction how to name ionic compounds and molecular compounds. There are also a lot of many practice quizzes from 100L5 Pack 1 all the way to 100L5 Pack 5. So all of this were practice quiz. You can try them as many times as you want until you become an expert in naming compounds. And the last two files, last two items, the second last one, second from the bottom, it's gonna be your lab report. So basically, you can try attempt this multiple times until you get a perfect score, which is 10 point. It's gonna be treated as your lab report, similar to your submission on Lab Archives, and the last item, which is your lab quiz. So it was 20 point. And this lab quiz, we only have one attempt. Basically, if you can master all the practice quiz and the naming report, you should do well on this lab quiz because lab quiz have so many similar or identical questions to your practice quizzes. So let's start from beginning the direction first. So in the direction, you're gonna find the basic order of this experiment. So I give you some introduction and then make sure you follow this guideline to complete this experiment. The next one is introduction. So introduction, it gives you the basic definition, what is the atomic elements and molecules elements, and compounds and molecular compounds. So make sure you read this to understand so you can identify it. You can classify which one is element and molecule and compounds. So for example, this practice, they're giving you the list of Fe and all the way to oxygens. So Fe, it should be atomic elements. PCl3, it should be molecular compound. Lithium, bromide, it should be ionic compound. And P4, it should be molecular elements. And oxygen gas, it should be molecular elements. And you also try this second set by on your own. So I2, it should be molecular elements. Helium, it should be an element. H2O, it had to be molecular compounds. Al should be elements. CuCl, it should be ionic compounds. And make sure you tell the difference between ions and ionic compounds. So for example, they're giving you this species and then you need to classify, is it an ion or is it a molecule? So ions suppose you have a charge. So ions, it's either positive or negative charge. So if you look at all of these species, whatever chemical formula having a charge, it had to be classified ions. So for example, NH4 plus, it's gonna be ammonium ion, so you're gonna put the X in here in this column, and SO4 2 negative, so 2 negative is the charged ion of this SO4, so it's gonna be ions, and CO3 2 negative, it's gonna be ions, and everything else neutral, NH3 and SO3, it's gonna be molecules. And so if they're giving you the species in name, make sure you can convert it to formula and identify is it an ion or molecule. So nitrate is an ion from your polyatomic ions. So this list of polyatomic ions you have to memorize. You need to memorize this to take the exams and the lab quiz. So you need to memorize this. Nitrate is going to be NO3 negative. So every time you have a positive one or negative one charge, the number one is going to be amide. so you only write down the negative charge. So nitrate, which is ion, it have negative charge 1, and carbon dioxide, which is CO2, so it's gonna be a molecules. And sulfite is S2 negative, so it's gonna be ion. Carbonate, which is this polyatomic ion, CO3 2 negative, so it's gonna be an ion. And sulfide trioxide, which is SO3, so it's gonna be molecules, SO3. So make sure you print out this paper models because you need to upload some of the puzzle ions compound in the next assignments. The next introduction, you need to write the name of ionic compound, convert the name into the chemical formula, and find out the number of positive ions, negative ions, and find out its ratio. So I already make the key in the next table. So make sure you try it on your own first and then compare with the keys. So for example, magnesium fluoride, the chemical formula is MgF2, and the positive ion, which is Mg, only one, and the two F, so it's gonna be two negative ions, and the ratio between the positive and negative, it can be 1 to 2. And same strategy completes the rest of this compounds. And you also can come up with some compounds using the ion provided. Using this ion provided, you can make up some new compound different than all of this. So the next assignment, which is the ion cut out. So this you print out, cut it into pieces, and you're gonna upload it your own. Make sure you watch the videos. There are also lecture videos that show you how to name ionic and molecular compounds, but these are extra videos you can watch it from other sources. So many videos you need to watch. So for your ion cutout, you need to make 4 new compounds and upload them into one file under this assignment. So it's gonna be created. So for example, I have made K2O. I cut it out and put it together, and you need to do 4 on your own and upload it similar to this. Make sure you include the name. So for example, this one is gonna be potassium oxide. So that is all about your lab experiment number 5. I also make the PowerPoint presentation overview, help you to name and recognize ionic and molecular compound. So nomenclature is just a technical term for naming chemical compounds. So there are 2 different types of compounds you need to learn for this assignment: ionic compounds and molecular compounds. So before you can name them correctly, make sure you recognize the structure of ionic compounds and the structure of molecular compounds. So ionic compounds, it contains metals ion, so metal always in front, list first, write out first, and then the second type of ion is going to be non-metals. For in molecular compounds, all the chemical formula contain non-metals. So for example, ionic compound, for example, NaCl, iron nitrate. So if you look at this chemical formula, you can recognize right away they are ionic compounds, not molecular compounds, because it's having a metal ion, which is sodium, and for the second chemical formula, the metal ion, which is Fe. Ionic compounds, it always contains metal ions combined with a non-metal ion. So Cl is the second ion, which is non-metal, and O3 is also treated as one polyatomic ions. So poly means many, atomic ion, which is NO3, one nitrogen combined with 3 oxygen to make up one ion, and this ion having a charge of -1. So make sure you review the list of polyatomic ions. You need to memorize them for this unit 2. So ionic compounds, it includes a metal combined with a non-metal. Metals is always having a positive charge, and the non-metal is always accept electron, which is will have the negative charge. There are two types of metal ions, so group 1A elements always giving up one electrons and become positive one. Or you can remove the number one, it's just positive side by only, which is mean one. And group 2A elements always having a charge of positive 2. Aluminum is always positive 3, zinc is always 2, and silver is always 1. And there are another type of metal ions called variable charge metal ions. So based on this table, I copy from your lecture note. So all the elements under group 1A always given up one electrons and become positive 1. All the elements belong to group 2A given up 2 electrons, losing given off 2 electrons and become positive 2. So for example, magnesium 2 plus, calcium 2 plus. So when they given up 2 electrons, it become metal ions. And everything in B groups, they are having variable charge metal ions, which is means they have more than one type of charge. For example, iron sometimes it have positive 2, the other time it have a charge of positive 3. Later, we're gonna show you how to know which one is iron 2, which one when it have a positive 2, when it have a positive 3. And non-metal ions, as we learned it from previous lab experiment, all the elements to the right side of the ball line, the step line, they are non-metal ions. And non-metal ions, they like to accept electron and become negative charge. So for example, group 1A is gonna have a charge of negative 3, 6A negative 2, and group 7A. Group 7A will accept one electron and become negative 1. So all of these are non-metal and they accept electrons to become negative charge. Metal ions, because it given up electrons, become positive charge. Electrons is a negative quantity, so if you're losing electron, you become positive charge. If elements accept electrons, it become a negative charge. Okay. And transition metals, which is group B over here, they having more than one type of charge. They are called variable charge metal ions. And there are two types of non-metal ions. So group 1A and 6A and 7A we have seen earlier have negative 3, negative 2, and negative 1 charge. Accept 3 electron, accept 2 electron, and group 7A accept 1 electron, become negative 1. And the second type of non-metal ions, there are lists of them you need to memorize. So I copied this from your lecture note from page 11. So make sure you have to memorize all of this chemical formula and its charge number. So for example, hydroxide, which is OH negative, this group is having a charge of negative 1. Poly mean many, atomic mean atoms. So it contains more than one atom to make up one polyatomic ion. So for example, in this ion, it contains one oxygen and one hydrogen. For example, phosphate group, we have one four combined with 4 oxygens become a phosphate polyatomic ion, and this group having a charge of negative 3. So make sure you memorize this table for polyatomic ion. There is only one polyatomic ion which is positive charge, which is ammonium. Ammonium, which is NH4 plus. So only this polyatomic ion having a positive charge. Everything else, polyatomic ion having a negative charge. Keep that in mind. So how to name ionic compounds? Depend on your ionic compounds, we can name it the different way. So for example, if you have simple charged metal ion, so you're gonna name it at its element's name. For example, sodium, it just named as sodium. And if you have a simple non-metal ion, so simple, which is mean it's not the polyatomic ion, you just name it as non-metal ion with the gender root into IDE. For example, sodium chloride. Sodium is named at its element. Chlorine become chloride, IDE. Same thing with silver bromide. So silver He, and bromine become bromide, IDE. So make sure you learn the simple non-metal ion names. So when you change it from element name to ion name of non-metal elements, you're gonna change it to IDE. Variable charged metal ion, which is transition metals, need to include the Roman numerals in the parentheses. So for example, iron nitrate. Iron is one of the transition metal having more than one type of charge. So make sure you include the Roman numeral number. In this case, iron have a charge of positive 3. So you're gonna put the number 2, which is Roman number, inside the parentheses, and nitrate, which is this group. Polyatomic ion, non-metal ion, so it's gonna be named as it is. If your ionic compound having a non-metal ion, which is a polyatomic ion, for example, barium sulfate and zinc phosphate. So make sure um, you recognize this polyatomic ion. PO4 is phosphate. So zinc, name what it is as a element name, and phosphate is one of polyatomic non-metal ions. So for molecular compounds, for example, if you look at this chemical formula, you can recognize it's not the ionic compounds because it contains no metal ion in the two chemical formula. SO2. So S is non-metal, oxygen is also non-metal. So this whole molecule is molecular compounds or covalent compounds, same thing. Pi2, P2I4, same thing. This chemical formula, it contains all non-metal. Phosphorus is non-metal. Iodide is also non-metal. So this chemical formula is considered molecular compounds. So I copied this from your lecture note from page 14. So make sure you review this with the lecture outline and the lecture videos for more details. So for example, if you given chemical formula SO2, so this SO2 is gonna be named as molecular compound. So it's gonna be sulfur name what it is, and two oxygen, so we're gonna name it dioxide. And P2I4, so you have diphosphorus tetraiodide. So this number is gonna be indicated by di and tetra. Tetra means 4. So they also can given you the name, and then you have to write out the chemical formula. For example, dinitrogen pentasulfide. If this name given, you know you need 2 diamine 2 nitrogen, and penta, which is 5 sulfide, which is S. And it should be S over here. It's not P. Let me fix it. Okay, and dinitrogen pentasulfide. And the last one, carbon tetrafluoride. So carbon, you only have one carbon with no prefix in front of it, no di or tri, so which is 1. Tetra means 4, fluoride, which is F, so CF4. Okay, so make sure you watch the videos in experiment number 5 on lab canvas, or watch the lecture videos to understand, to get more instruction how to name ionic compounds and molecular compounds.